This demonstration will illustrate the exchanges between the CSMS, which manages the EVSE reservations of a geographical area, and a charging station using the IEC63110 protocol currently being standardized, and which is based on the XMPP messaging protocol. We will therefore illustrate the following use case. This is the realization of the programmed discharge of a vehicle. The scenario followed, illustrated by the sequence diagram, involves two physical actors, namely the vehicle user, EVU, and the flexibility operator, FO, as well as three system actors, the electrical vehicle system software, EV, charging station, CS, system software and CSMS system software. In this demonstration, we do not illustrate the exchanges between EV and FO, which are carried out either in IEC 63110 or in IEC 62325, CIM. It is assumed that these exchanges allowed the CS to store a reservation of EVSE for the Simcardo vehicle and the user Andre, between a check-in time of 0:20 and a check-out time of 3 o'clock for a coordinated discharge with the FO of 80 kWh, between a start time of 0:40 and an end time of 2:04. We will follow the exchanges between the CS and the CSMS, which will translate on the consoles by the traces of the messages exchanged and on the CSMS HMI by visual changes. We will thus trace for IEC 63110 messages that accompany the four events traced by the CSMS. The vehicle electrical connection message to an available EVSE. The message when the discharge starts. The discharge is then done until the message of end of discharge. Followed by the EVSE release message from the vehicle indicating the vehicle's departure. The items on the demo screen are: the CSMS displays the occupancy indicator of an EVSE, in green if free, in red if occupied, and the data marking the time of the various stages and finally the energy to be exchanged planned or otherwise, the total energy exchanged. The CSMS Application Console. For CSMS, XMPP was launched with the debug option, so messages received by CSMS are written to this console when they appear. The console of the station application. This console displays XMPP and service messages. The vehicle HMI. This interface allows to connect the vehicle in Wi-Fi, then to connect electrically to an EVSE, and to start the discharge. The HMI of the Local Energy Management Service, LEMS, which is connected to the station by the IEC protocol 68150 and which allows by a proxy to visualize the vehicle data. The demonstration begins with the launch of the CS station system software. Some messages reflect exchanges with the CSMS for the station to retrieve EVSE reservation data. The vehicle driven by Andre approaches the station and connects to Wi-Fi. The station notes that Andre has reserved a EVSE for a discharge. It therefore sends a connection authorization message to the vehicle and displays it on the IHM. You can connect. Once connected electrically, the CSMS receives the XMPP connection message. The CSMS updates the arrival time and the EVSE occupancy indicator changes to red. The vehicle is then ready to start the discharge. The driver clicks the start button and the discharge starts. The CSMS then receives the XMPP startup message and updates the discharging start time. Discharging then takes place, and the HMI eval EMS reflects the progression of the vehicle data. In particular, we note the decrease of the SOC, which reflects the discharge of the battery. The end of the discharge is detected either because we have transferred all the planned energy or because we have arrived at the expected end of the bid. The end of charge message is then received by the CSMS, and the end time and the sum of the transferred energy are displayed. At its convenience, the vehicle disconnects electrically and moves away. The outgoing message is then received by CSMS and the occupancy indicator of EVSE is set to green.